Hi, this is Ms. Hogan. Today we're going to discuss how to solve systems of equations with graphing. As it is our first lesson of the unit, just thought it would be helpful to sort of reinforce what are systems of equations. So believe it or not, you were kind of introduced to this in our last unit when you were graphing something that had two variables. So we're going to build on that knowledge and continue by talking about equations rather than inequalities. So systems of equations are just two or more equations with the same variables. And obviously you're taking notes with me. So you have learned and spent a lot of time working on like how to graph things in slope-intercept form. You did a beautiful stained glass project on it. So we know that when we're graphing something, it tells us a lot about that equation. When we have more than one equation that we're graphing, the solution to that system is where the two lines intersect. So it's a point on the graph where the two lines are intersecting. You'll see in a moment what I mean. Algebraically, which we'll explore in later lessons, the solution of the system is the point xy that makes both equations true. So we're kind of shifting gears back to equations. We spent some time talking about inequalities. So now just, we're talking about equations. Okay, so there are three types of solutions based on the types of lines that you're going to be graphing. So intersecting lines are probably what you'll see most often, and that looks exactly like it sounds. They're two lines that are intersecting. They're crossing at a point on the graph, and for example, like this point would be your solution. Those types of problems have one solution, and you would write that solution as a coordinate on the grid, so x, y, whatever those numbers are. Then, of course, there are two special cases, so to speak. So if I had parallel lines, as a reminder, never intersect, it makes sense that they would have no solution because there's never a point at which they are intersecting. So parallel lines have no solution. Sometimes you might see that written as like a 0 with an X through it, but you could also just write no solution. Okay, and then think if we have a line that you start off with an equation and it ends up being the same exact line as the other equation. It might not look like it initially, but once you move things around and graph it, you end up with two equations that have the same line on a graph. So on a graph, you would have the same thing. I'm just going to draw like an extra arrow here so you can kind of see that it would be like another one extending. Same exact line. Okay, so where are the points on the graph where that's sort of like having something in common? The points on this graph that are having something in common are every single point. Every single point on this line is a solution because they're the same lines, meaning that it's an infinite solution. And an infinity symbol looks like this, so if you ever see that as a solution, that's what it means, infinite solutions. Okay, so those are the three types of solutions we're looking for when we're graphing. How to get there is what we're going to discuss next. So when you're solving systems by graphing, there are basically three steps. The first step, and you kind of explored this when we were dealing with inequalities, is we need to rewrite the equation in slope-intercept form if it's not already there. That just makes it really easy to decide what my slope is and what my y-intercept is, which is information that I need to graph the linear equation on a graph. The second step is then to graph it. So we're going to graph each line. And then the third step is to identify the solutions. So again, we're looking for one of the three things above. Okay, so we're going, as usual, to start off a little bit easier and then we'll build up. So we're going to do two examples today together, examples 1 and example 3. I would like you to try a few more examples on your own and then you can check your answers on MyBricks. So these are easy intentionally because I want you to sort of just see what's going to happen. I say they're easy because they're already in slope-intercept form. There's nothing for me to do here or here to get them in slope-intercept form. They're already there. So let's just focus on what we do next. So of course you know that in this equation here, my slope is 1 and my y-intercept is -8. So just a introduction into graphing. So your y-intercept is what I like to plot first. -8, 1, 2, 3, 4, 5, 6, 7, 8 goes here. And then my slope is 1, which is really nice. So that one just goes up 1 over 1 for the whole line. So you can have some going in both directions. Okay, then I'm going to draw my line a little bit easier on notability. Okay, so this one is finished. Now it's time to graph the other one. This one has a y-intercept of +1 and a slope, I'm going to do this one in a different color actually, and a slope of -2. So this negative slope can look a couple different ways. We've been talking about this a lot and sort of like remembering that like it can mean, if we're thinking about slope and it's negative, it can mean down and to the left. No, sorry, that's not right. Down and to the right, my bad. But it could also mean up and to the left. Notice how like one direction is negative and one is positive. Whereas like if you needed to go around the graph in another way, you could also do it like, okay, my rise is positive, but my run is negative. Both of those would work. I say that because I've noticed like a lot of people when they're making their graph, they're like, oh gosh, I can't go above this. Remember, you can also go like, that looks like a person. You can also go different ways around the graph. Okay, now I'm getting on a tangent. Anyway, we are graphing this line. So our y-intercept is 1, and then we're going down 2 over 1. Down 2 over 1. Down 2 over 1. Check it out. I already know before I even draw the line where the solution is going to be. Down 2 over 1. Okay, so a question I bet you're all thinking is, how many points should you plot before you draw the line? Well, in my opinion, just to be like accurate, I would draw these points until you find the solution. Because if you're relying on drawing the line to find your solution, there are more things that could go wrong. You've all seen it happen with yourselves when you're like using a ruler and like if it's not exactly perfect. Even mine on notability, check it out. Like, okay, well, this one's an easy line, but you'll see on the next one. So I would do as many points as possible to get a solution. Notice like I didn't do that many over here. I don't really need those. I'm looking for what the solution is. So the solution is where they intersect. And for this line, that is at 1, 2, 3. So my x-coordinate is 3, and my y-coordinate is 1, 2, 3, 4, 5. -5. 3, -5 is a solution to this system. It's where the two lines share a point, essentially. Okay, we're going to skip 2 for now and go on to number 3. So number 3 looks like this. What I want you to do now is pause the video and rewrite it in slope-intercept form, and then you're going to graph it. Okay, welcome back. So when I rewrite this into slope-intercept form, I'm left with y equals 3x plus 8, and then I'm left with y equals x minus 2 for my second equation. So when I'm graphing the first equation, I am going, this one's pink. So notice, this is a perfect example of like what I was talking about earlier. My slope for the pink line is 3, and my y-intercept is 8. So when you go up to 8, you might be thinking like, oh gosh, I can't go up higher any longer. But remember, a positive slope could be up and right, but it could also be down and left. And again, here's why. These are both negative. If you think of like a fraction, like if you're going down 3 and to the left 1, this equals positive 3. So you have the same slope. It's just like it's helping you orient around the graph in a way that makes sense for the next line. So I did that here. The blue line, it has a y-intercept of -2 and a slope of 1. So I'm going up 1 over 1, up 1 over 1. Okay, I noticed as I was drawing this that these parts of the lines were never going to intersect. So I stopped drawing points on this line and went, well, wait a second. I'm going to go back to my y-intercept of -2 and continue that line going this way so I can actually see where they meet. So if you didn't do that and you just drew the line, that's okay, but I would wonder if you got as precise of a point. So when you go down 1 over 1, down 1 over 1, you get this solution, which is where they both meet. So that solution is -5, -7. I feel like this unit is really reinforcing a lot of what we talked about in Unit 1 with graphing. So if you're watching this and you're like, what am I talking about with the slope? Don't worry. This whole unit is basically a lot of graphing and solving equations. So we'll continue talking about that. I would like you to pick 2 other examples from your notes and check your answers on MyBurks. Thank you for your hard work. Have a great weekend.